Welcome back to Meteorology Matters, everybody. Today we're going to be talking about, Asteroid 2024 YR4.
Yeah.
I don't know about you, but when I first saw those headlines about, a possible impact
Oh, yeah.
in 2032, I was like, what?
It definitely got people talking.
Yeah, my jaw kind of hit the floor.
Yeah, those early reports were saying like a 3.1% chance of impact, and for an asteroid that size, it's pretty unprecedented.
Yeah, 3.1%, on the surface doesn't sound like a lot, but then you start hearing people toss around terms like city killer and, it's hard not to feel a little uneasy, right?
Yeah.
What exactly makes this asteroid so potentially dangerous?
It really all comes down to its size. 2024 YR4, it's estimated to be somewhere between 40 and 100 meters wide. So
Wow.
to put that into perspective, that's bigger than a football field. So if something that big were to hit Earth, it would, cause some serious damage, potentially localized devastation.
Okay, so not something you want in your backyard. But the thing that's really tripping me up is how this probability keeps shifting. Why all the uncertainty about its path?
Well, predicting an asteroid's trajectory, it's constantly evolving. When 2024 YR4 was first discovered back in December, we had very limited data to work with, and as astronomers make more observations, they can refine their calculations and get a clearer picture of where the asteroid is headed.
So the more we learn, the more that probability can change, even going up temporarily.
Yeah, exactly. Think of it like this. Imagine shining a flashlight in a dark room.
Okay?
Initially, you see a wide beam of light.
Uh-huh.
But as you adjust the focus, the beam narrows, and for a brief moment, the brightest part of the beam might actually seem smaller
Yeah.
before settling on, a specific point.
Yeah.
Similarly, as we gather more data about 2024 YR4's path, the range of possible trajectories narrows.
Right.
And that can lead to a temporary spike in the calculated probability of it hitting a particular area, even as the overall risk decreases.
Okay, that makes a lot more sense. It's not that the asteroid is suddenly becoming more dangerous. It's just that our understanding of its path is becoming more precise.
Exactly. And as we continue to monitor its trajectory, chances are that that calculated impact zone will shift away from Earth altogether. We've seen this happen before with the asteroid Apophis back in 2004. Initially, there was concern about a potential impact in 2029, but further observation that completely ruled it out.
So what's the latest on 2024 YR4? What are scientists doing to keep tabs on this thing?
Astronomers all over the world are using a variety of telescopes to track its movement and get this. They're even using the James Webb Space Telescope to get a closer look.
Wow, the James Webb, that's serious firepower. What kind of information can they get from that?
The James Webb is incredibly powerful, especially when it comes to observing objects in infrared light. This will allow scientists to gather much more precise data about 2024 YR4's size, shape, and composition. This information is crucial for refining our understanding of its trajectory and ultimately determining the actual risk it poses.
Sounds like they're pulling out all the stops to get a handle on this. So let's say, hypothetically speaking, that the risk remains high and this thing really is on a collision course with Earth. What then? What can we do to prevent an impact?
That's where things get really interesting. While it might sound like something out of a science fiction movie, there are several potential methods for deflecting an asteroid.
Like what?
One of the most promising is what's called the kinetic impactor.
Kinetic impactor. Okay, lay that on me. What does that even mean?
It's actually a pretty straightforward concept. You basically launch a spacecraft at a very high speed and crash it into the asteroid. The goal is to transfer enough kinetic energy to nudge the asteroid slightly off course enough to avoid a collision with Earth.
So like a cosmic game of billiards, but with much higher stakes.
Exactly. Of course, the challenge lies in calculating the exact force and angle needed to achieve the desired deflection without accidentally causing the asteroid to break apart in an unpredictable way. And that's where things get incredibly complex, requiring sophisticated physics and mathematical modeling.
Right, you don't want to trade one big problem for a bunch of smaller but still dangerous ones.
Exactly. So while the concept is relatively simple, the execution is anything but.
Well, this is already so much to absorb. We've gone from initial panic about a potential impact to talking about high-tech space billiards. But before we get ahead of ourselves, let's take a moment to remind our listeners where they can find more content from our show and our host, the amazing Rob Jones.
Absolutely. Remember, folks, you can follow meteorologist Rob Jones on Instagram, TikTok, and YouTube to delve even deeper into the world of weather and space.
That's right. You can find Rob on Instagram at Meteorologist, on TikTok at TV Meteorologist, and on YouTube, be sure to follow Rob Jones Hurricane. That's also where you can find the Meteorology Matters podcast playlist.
Yeah, and speaking of the podcast.
And speaking of the podcast, when we come back, we'll explore some of those other asteroid deflection methods, including one that sounds straight out of a Hollywood blockbuster. Stay with us.
Welcome back to Meteorology Matters, everyone. Before the break, we were talking about, using a spacecraft as a high-speed projectile to nudge an asteroid off course, those kinetic impactors.
It's just mind-blowing to think that we're even capable of considering something like that.
Yeah.
Did we ever actually test this theory out?
We did. You might remember NASA's Double Asteroid Redirection Test, or the DART mission, back in 2022.
Okay.
They intentionally crashed a spacecraft into a small asteroid named Dimorphos.
Okay, yeah, I vaguely remember that. Now, Dimorphos was part of like a binary asteroid system, right? Meaning it was orbiting a larger asteroid, and the whole point of this was to see if we could actually change its orbit.
Yeah, that's exactly right. It was the perfect real-world test case because Dimorphos posed no threat to Earth.
Right.
The mission was purely about proving that we could, in fact, alter an asteroid's trajectory using a kinetic impactor.
And what were the results? Did we manage to move it?
It was a huge success. After the impact, scientists observed a measurable change in Dimorphos's orbit around its larger companion.
Wow.
Yeah, it was groundbreaking data that showed we have the capability to deflect asteroids if needed.
So we've moved from theory to actually proving it can be done. That's incredible. But you mentioned other deflection methods as well.
Right.
What else is on the table?
Well, there's another approach that has been explored, although it's significantly more controversial.
Oh,
And it involves using a nuclear device to either completely obliterate the asteroid or shatter it into smaller pieces, hopefully small enough to burn up harmlessly in the Earth's atmosphere.
okay. I could see why that one's a little bit more delicate. Aside from the obvious, safety and ethical considerations, wouldn't it be incredibly difficult to control the outcome of such a massive explosion?
Yeah, absolutely. It's a highly complex and inherently risky proposition. Using a nuclear device could create, a shower of smaller fragments that might still pose a threat.
So it sounds like the kinetic impactor, while still a massive undertaking, is the more controlled and predictable option at this point.
That's the general consensus within the scientific community right now, but, it's an ongoing field of research, and both approaches have their own sets of challenges and uncertainties.
This is also fascinating. We're talking about deflecting asteroids, something that just a few decades ago would have seemed like pure science fiction.
Oh, no.
It really speaks to the incredible advancements we've made in space exploration and technology. But all this talk about asteroid threats and potential deflection methods has me wondering, what if we did have to face this scenario for real? What would the human element look like?
That's a crucial aspect that often gets overlooked. The logistical and societal challenges of dealing with a potential asteroid impact would be immense,
Yeah,
even if we had the technology to deflect it.
I can only imagine, how would we even begin to prepare for something like that? Evacuating entire cities or regions potentially on short notice, that would be a monumental task.
It would require a level of global cooperation and coordination that we've frankly never seen before. We need clear communication channels, comprehensive emergency response plans, and resource allocation strategies on a global scale.
The sheer scale of it is almost overwhelming to think about it. It really underscores how interconnected we are as a species, and how a threat like this would require a truly unified global response.
Without a doubt, it would force us to confront, these fundamental questions about our priorities, our values, and our responsibility to protect not just ourselves, but future generations.
It's almost philosophical, isn't it? We started out talking about space rocks and deflection technologies, and now we're delving into these profound questions about humanity's future and our place in the cosmos. It's amazing how these topics can lead to such deep reflections.
It's a testament to the power of scientific inquiry, to spark these broader conversations about who we are and how we interact with the universe around us.
Well said. This has been an incredibly thought-provoking conversation so far. We've covered a lot of ground, from the science of asteroid detection and tracking to the potential methods for deflecting them, and even the profound societal and ethical implications of a potential impact.
It's been a fascinating journey for sure.
Before we continue, let's remind our listeners where they can connect with our host and find more great content. You can find Rob on Instagram at Meteorologist, on TikTok at TV Meteorologist, and on YouTube, make sure to follow Rob Jane's Hurricane. You can also find the Meteorology Matters podcast playlist there.
And when we come back,
we'll wrap up this episode with some final thoughts and a question that we hope will stay with you long after the episode ends. Stay tuned. Welcome back to Meteorology Matters, everyone. We've been having a fascinating discussion today exploring the potential threat of Asteroid 2024 YR4 and the incredible technologies being developed to deflect asteroids. But before we wrap up, I want to circle back to something we talked about earlier, something that really struck me, the human element of all this.
yeah, it's a critical aspect, that's for sure. The science and technology are fascinating, but at the end of the day, it's about people about safeguarding humanity and our future.
Exactly. Imagine the global impact if we knew for certain that an asteroid was on a collision course with Earth. Even if we had the means to deflect it, the societal and political ramifications would be immense.
Absolutely. Think about the decisions that would have to be made, the potential for disagreements, even conflicts over the best course of action. Who gets to make those calls? How do we ensure fairness and transparency in such a high-stakes situation? These are questions we need to grapple with now before we're faced with an actual crisis.
It's almost like a real-life ethical dilemma on a global scale. And then there's the question of public perception and communication. How do you even begin to explain such a complex and potentially frightening scenario to the world without causing widespread panic?
Yeah, that's a huge challenge. It highlights the need for clear, accurate, and timely communication from scientists, policymakers, and the media. Building trust and understanding with the public is paramount in a situation like this.
It's so much more than just the science. It's about understanding the human psyche, the complexities of global politics, the power of communication, and ultimately our shared responsibility for the future of our planet.
It truly underscores the interconnected nature of our world and the need for international cooperation and collaboration on an unprecedented scale.
It's a sobering thought, but also strangely inspiring. It makes you realize that we're all in this together, facing these cosmic challenges as one species.
It's a reminder that while we might have our differences, there are some threats that transcend borders and ideologies, threats that demand a united front.
Well, on that note, I think it's time to bring this episode of Meteorology Matters to a close. We've explored some complex and thought-provoking topics today, from the science of asteroid detection and deflection to the profound societal and ethical implications of a potential impact.
It's been an incredible journey, and I hope our listeners have gained a deeper appreciation for the wonders and challenges of the cosmos and our place within it.
Before we sign off, let's remind everyone where they can find more content from our amazing host, Rob Jones. You can catch Rob on Instagram at Meteorologist, on TikTok at TV Meteorologist, and on YouTube, don't forget to follow Rob Jones Hurricane, where you can also find the Meteorology Matters podcast playlist.
And as always, we encourage everyone to stay curious, keep exploring, and never stop asking questions about the world around us.
Beautiful said. Thanks for joining us on Meteorology Matters. Until next time, stay safe, stay informed, and keep looking up at the stars.